Use Descartes' rule of signs to determine the maximum possible numbers of positive and negative real zeros for the function f of x equals to x to the fourth power minus 10x cubed plus 11x squared minus 15x plus 12. Then use a graph to verify the numbers of positive and negative real zeros for the function. A part of the Descartes rule of signs requires that we check the variation of f of x and f of negative x. We see that f of x equals 2x to the fourth minus 10x cubed plus 11x squared minus 15x plus 12. This is already written in descending order or decreasing order of the power. From the leading term to the next term, the sign changed, so we have one variation. And then to the next term, the sign changed from negative to positive, so we have another variation. Positive to negative, another variation. And then negative to positive, another variation. And so there are 4 variations for f of x. Descartes' rule of signs states that the number of positive real zeros of the function is equal to the number of variations. So the number of positive real zeros is either 4 or less than that by an even whole number, and so we need to subtract an even number 2. And so 4 minus 2 less than an even number. The even number that is less than 4 is 2. And then lastly is 0. And so there are 2 possibilities here, either 4 or 2 positive real zeros. We also need to check the sign of f of negative x, the variation that is. We simply plugged in negative x into where x is, and so we will replace this function with negative x instead of x. That is, everywhere we see an x, we simply replace it with a negative x. The input is now negative x. The quantity negative x to the fourth is positive x to the fourth, so this is 2x to the fourth. The quantity negative x cubed is negative, and multiplying negative 10 is positive 10, so this is 10x cubed. The quantity negative x squared is positive x squared, so this is plus 11x squared. Negative times negative is positive, and then we bring down 12. There is no variation from the first term to the second term because the sign doesn't change. 0 variation for the next pair, 0 variation, 0 variation. One thing to keep in mind that this is already arranged in decreasing order, 4, 3, 2, 1, 0. In this case, there are 0 variations for f of negative x. The Descartes rule of signs state that the number of negative real zeros is either 0 variation or less than that of an even whole number. Now, the number of real zeros is going to be positive or 0, but in this case, there is no even number that is positive but less than 0. So in this case, there is no negative real zeros. We summarize the results in this table. There are 2 possibilities, or 3 possibilities for the positive real zeros in this case, and they are 4, 2, or 0. There is 0 number of negative real zeros. And so we simply list the possibilities here for positive real zeros, 4, 2, or 0. And we again list the number of negative real zeros for each of the corresponding positive real zeros. This is the function with degree 4. And so we would have up to 4 total zeros. Up to, not 4, but up to 4. It can be less or 4. If there are 4 positive real zeros and 0 negative real zeros, then there should be 0 non-real zeros. If there are 2 positive real and 0 negative real, then there must be 2 non-real zeros. And if there are no positive and no negative, so there should be 4 non-real zeros. And again, the function of degree 4 has up to 4 total zeros, non-real and real included. Next, we're going to use the graph to verify the number of positive and negative real zeros only. To do this, we simply sketch the graph of the function f of x. The graph of the function f of x shows that there are 2 x-intercepts. This is where the graph crosses the x-axis. So there are 2 real zeros in this case, and the x-intercepts are positive, therefore there are 2 positive real zeros for the function.